Sometimes we need to measure certain physical quantities like pressure, temperature, weight, or generally any quantities that change continuously using a PLC. For this, we require analog inputs. The H-series PLCs that you are learning about do not have built-in analog inputs, so we need to add them via an option card. These cards come in either 4-channel or 8-channel versions, and there are two models, Series A and Series C. If the last letter in the card's code is A, it's a 12-bit card. If it's C, it's a 14-bit option card. Now, what's the difference between 12-bit and 14-bit cards? The 14-bit option card has higher resolution and accuracy. Here we have an AD04A card, which means this is a 4-channel 12-bit card. As you can see, it has 4 input channels, and for each channel there is a DAP switch at the top that lets you specify whether your input is an analog current or voltage. Also, as you can see, there are some pins next to the option card which connect to the PLC in this way. Now that the card is attached to the PLC, we need to configure the option card settings in the XG5000 software. But before we go into the settings, let me mention that you need to connect a 24-volt power supply to the option card for it to turn on. After entering the XG5000 software and selecting the PLC model, double-click on I/O parameter in the left window. A new window will open. In this new window, in the first row under Model, we again specify our PLC type, which is DR32H. In the second row, we need to specify the type of option card we added to the PLC. Since we added an analog card, we select the second option, Special Model List. And because our card is an analog input, we choose the Analog Input Model option. Then we need to select the option card model, which is AD04A. The next step is to double-click in the comment section, which opens a new window. In the first part, we set each channel we need to enable, and in the input range section, we specify the type of input signal, whether it's 0 to 10 volts, 0 to 20 milliamps, or 4 to 20 milliamps. We select 4 to 20 milliamps. The next step is to specify in the output data type section what range of numbers this 4 to 20 milliamp signal should display in the PLC, or in other words, to set the reading accuracy for the analog signal. There are different ranges, but we usually select 0 to 4000, meaning 4 milliamps corresponds to 0 and 20 milliamps corresponds to 4000. The next step is in the filter processing section, where a software filter is applied so that changes in the input are not instantly reflected in the output. If we set it to enable, this feature will be activated. In the next section, the filter constant, we specify the filtering time from the previous section in milliseconds. The next step is the average processing section, where if we set it to enable, it calculates the average of the input signal for us. So what exactly does it average? In the next section, average method, we determine this. And there are two modes. One is count average, which is based on the number of samples, and the other is count timer, which is based on time. Finally, in the average value section, we specify the averaging amount, meaning how many of the last values or how many of the last seconds should be averaged.